Here are your video notes for lesson 4.1. Now I want to start on page 268. I'm going to skip page 267. So at the top of page 268 it says tables, graphs, and equations. It says recall that an equation is a mathematical sentence stating that two quantities are equal. A linear equation, which is a vocabulary word, is an equation with a graph that is a straight line. Go ahead and box, circle, whatever it is you want to do to this, because that's something that we all need to remember. So here it also says that some equations contain more than one variable. Example 1 here. The table shows the number of liters in quarts of liquid. Write an equation to find the number of liters in any number of quarts. Describe the relationship in words. So this first part says to write an equation. The reason we would want to write an equation is because let's say we have like 50 quarts. I don't know about you, something like this, of course. I don't want to list all the way down to 50. So with something like this, you are bound to find some type of pattern. And you can see here that each one of these is going up by 0.95. So each time it moves up, each quart, you could say, is equal to 0.95 liters. You could say that. And actually right here, they use the equation y2 minus y1 over x2 minus x1. Or you could just think about, okay, I'm going to take 1.9 minus 0.95 and then 2 minus 1. Either way, you're going to get the same thing, and it's 0.95. So it says the rate of change is the rate that describes how one quantity changes in relation to another quantity. The rate of change of quarts to liters is, and here's where they figure it out. You could show this as work right here, and I'd be fine with that as long as you know what you're doing. Now, if these are not going up by the same one each time, you're going to have to do a little bit more math. So down here it says let L represent the liters and let Q represent the quarts. So this equation is liters, because L stands for liters, equals 0.95 quarts. That's what that means. So let's go ahead and look at 2. It says about how many liters are in 8 quarts. So you could list out a huge table here that counts all the way 1, 2, 3, 4, 5, 6, 7, 8. Go for it. But our numbers are going to start getting bigger. And I already ran out of room. I'm not going to do it. So instead, I'm going to use our equation that we wrote. Liters equals 0.95 quarts. And I'm going to replace Q with 8. I'm going to plug in 8 because it's asking how many. Yeah? How many liters are in 8 quarts? Plug in 8 for Q, multiply. So there are about 7.6 liters in 8 quarts. All right, let's we can try these 2 examples. This is at the bottom of page 268. Says the total cost of tickets to the school play is shown in the table. So we have our table here. Number of tickets, T, total cost, C. So 1 ticket costs $4.50, 2, $9, 3, $13.50, and then 4 is $18. Write an equation to find the total cost of any number of tickets. Describe the relationship in words. So right here we have number of tickets is 1. Each one of these is pretty obvious it's going up by 1. Now to get from 450 to 9, you could try to estimate here, or I could do, okay, what is 9 minus 450? Well, it happens to be 450. And then if I go from 9 up to 1350, we add another 450. And then from 1350 to $18, we add another 450. So this is pretty consistent. It's going up. So I know that the total cost right here, C, is equal to, now I have to take the rate of change, which we also know is slope, 450 times, we're multiplying, the number of tickets. Oh, so sorry. And this is what they did on the last example where they wrote the equation, times T, which makes sense because let's say you get 12 tickets for family and friends, you multiply it by 450, that's how much it's going to cost you. So I'm just going to write the equation over here. If you're asked to describe it in words, which, you know, that's good practice to do, and you're probably going to have to do it, Describe the relationship in words. Well, you could say something like the cost goes up by $4.50 each time you buy a ticket because each ticket costs $4.50. Now it says use the equation to find the cost of 15 tickets. Well, if I want to know what the cost of 15 tickets is, all I have to do is plug in. I have my equation right here. I need to know, okay, the cost for 15 tickets. So I have cost is equal to $4.50 times how many tickets I want, which in this case is 15. So $4.50 times 15 gives me, multiply those out, 67.5. So since we're dealing with money, I'm going to put our money symbol. That's $67. That's not 5 cents. It's 50 cents. $67.50 for 15 movie tickets. Really, $4.50 is cheap. All right, number 3. So this is on page 269. So the total distance Marion ran in 1 week is shown in the graph. Write an equation to find the number of miles ran, y, after any number of days, x. So we need to write an equation, which means we need to make it look like y equals mx plus b. This should be familiar to us. In order to do that, all we have to do is pick 2 points. It looks like they, if you look down here at their step 1, they did 14. So they did 4.14 and then 2.7. Well, you could really pick any 2 of these points. I like to choose the 2 lowest points. And I take the y's and I subtract them. So 7 minus 3.5 is going to give me 3.5. Over 2 minus 1 gives me 1. Well, even though I just used 2 different points, I still got the same answer, 3.5 over 1. Now I need to find the y-intercept. And if you do not have a graph that goes all the way through and does not connect to this y-intercept, it's going to be a little bit more difficult. But it shows you how right here. So to find the y-intercept, use the slope and the coordinates of a point to write the equation of the line in slope-intercept form. So we have y equals mx plus b. We plug in our slope. We just found this. Now they chose a point. Looks like they chose the second point. I would tell you to always just choose the first point because that way you don't have to worry about figuring out which is which. So if I have y equals 3.5x plus b, I'm going to use the point 1, 3.5. So 1 is my x, 3.5 is my y. If y is equal to 3.5, well, I need to write that instead of the y equals 3.5 x, and x in this case is actually 1, so times 1 plus b. And then I can just solve for my b and find my y-intercept this way. So I have, let me rewrite this, 3.5 equals, well, 3.5 times 1 gives me 3.5 plus b. And if you can't see it already, you're going to realize I need to subtract 3.5 from both sides. These cancel, and 3.5 minus 3.5 actually gives me a 0. So my b, in this case, which they got the same answer to, is 0. So if we want to write this as an equation, and if you look way down here, I know I have a lot written, it says the slope is 3.5 and the y-intercept is 0. So the equation of the line is y equals 3.5x plus 0. Or another way to write it is y equals 3.5x. Either way. All right, number 4, it says, how many miles will Marion run after 2 weeks? And this comes from the same previous problem there. We have the equation, which is y equals 3.5x. If we want to know how many miles will she run after 2 weeks. Now, the reason they put it into 14 days is because if we take a look at our chart here, our graph, we're talking about days. We're not talking about weeks. So pay attention. They're trying to kind of mess you up here. So put in a 14 and then multiply. So in 2 weeks or in 14 days, she's going to run 49 miles. All right, the do-it-yourselves got it check problem at the top of page 270 says the number of trees saved by recycling paper is shown. So this will be our last example we do together. And you can see here that all of these points, so we have total trees saved and amount of paper recycled in tons. Now, just a little quick fact, 1 ton equals 2,000 pounds. Okay, just keep that in mind. So 1 ton is a lot. That's a 2K, like 2,000. Ran out of room. Okay. So it says to write an equation to find the total number of trees Y that can be saved for any number of tons of paper. If we need to write an equation, I need to find my slope. I need to find my y-intercept. Yeah. So to find my y, or I guess I'll start by finding slope, and then I'm going to show you a shortcut. I'm going to show you a little cheat. Okay, so I need to find 2 points. These 2 points I'm going to use, I'm just going to use the first 2 points here. Oh, hold on a second. All right, so I'm going to use 2 points, and I usually almost always just take the first two. So I have 117 and 234. Take your y's and subtract them. So like for the first one, I'm going to do 34 minus 17. So I'm going to get it 17 over 2 minus 1, which is 1. So my slope for this one, 17 over 1. Now, if I want to find my y-intercept, I have to do kind of the backwards thinking because I'm not sure where these are. I mean, I could probably take a good guess, but since the line is not drawn in, I can't say for certain what my y-intercept is going to be. So I have y equals mx plus b. I need to replace what I know, and right now all I know is my slope. So I have y equals 17 over 1 or 17. They're the same. X plus b. If I want to find my y-intercept b, what I need to do is pick a point. I always pick the first point. So I have x is 1, y is 17. And I plug those in. So I have 17 equals 17 times the number I have for x, which is 1, plus b. Now when I do this, I get 17 equals, 17 times 1 gives me 17 plus b. Now I need to get the b by itself by subtracting 17 from both sides. These cancel. Well, 17 minus 17 gives me 0 equals b. So I have m is 17 over 1 or 17 and b equals 0. If I were to write that as an equation, it would look like y equals 17x, and I could put plus 0 or not. I think it looks better when you just don't write the plus 0, just because it's mathematically not correct. So now D says use the equation to find how many trees could be saved if 500 tons of paper were recycled. So remember, and also I guess really technically we could write this y equals 17x as I guess total trees saved, so we could say T total trees is equal to 17 times amount of paper recycled. We could say like P or even R, whatever. The variables really don't matter. So I just need to know where to plug in. If 500 tons of paper are being recycled, well, I have T equals 17 times that amount of paper. I'm going to do 17 times 500. And that's going to give you how many trees were saved. And we could do something like 17 times 500, which is equal to 8,500. Now, it's not just like 8,500, just the number. It's 8,500 trees.